Let's visualize how we have to visualize while figuring out the volume of solids with known cross sections, right? Because once we can visualize it, it becomes that much more easier to do the calculations. Okay, so let's go to geogebra.org, start calculator. Let's go to 3D calculator, and here we require a range of x from this figure to this figure. So let's say a, b, and since we are going to integrate it, so we need to create multiple figures. So let's say n is equal to slider from a to b in steps of zero point 0.1. So let's make sure that this is values. Now let's define the functions. F of x is equal to minus x square by 9 plus 1. And the x values are from minus 3, or let's say a to b. That is, a is less than or equal to x, which is in turn less than or equal to b. And let's actually give proper values for this based on this function. So minus 3 to, now we want the second curve. So g of x is equal to, let's say, 1. No, let's say g of x equal to 0 itself. And for this also, let's restrict the domain. A is less than or equal to x, which is in turn less than or equal to b. So this is the figure we have got. So this will be the base of the figure, right? Solid that we are going to build. Now, depending on what solid we are building, we have to define or identify the coordinates. Okay, so let's define the coordinates. N comma f of n will be a point on the green curve. Then n comma 0 would be the point corresponding to that on the x-axis. In this particular example, we are looking at squares. So we want to build a square, right, on top of this. So what would be the third coordinate? Third coordinate will be n comma f of n, and naturally this will come into the third dimension. So we have to provide the coordinates of the third dimension also. So let us say f of n itself. So you notice third corner has come of the square. Now the fourth corner. So n comma 0 comma f of n. And now if you rotate it, you can make out a square, right? But to really to make it appear as a square, let's convert that into a polygon. So polygon a comma b comma d comma c. Now you can actually make out a square, and I'm going to hide the points because I don't want the points to be visible. And let's zoom in a little bit. And now what I'll do is this n value I'll shift. So what happens? Or let me animate it. Yes. So this is our solid that is being formed by this square as it moves along these between these two curves. Okay, so I want to be able to see or visualize the figure that is being built. So let's show trace, activate this. So now as it moves, it will leave a shadow, right? And you can make out the solid that is being formed by this moving square. And the size of the square, depends on the base being formed by these two curves, the enclosed space between these two curves. Yes. We have to figure out the volume of this figure. And if I rotate it, you can actually see each of those individual squares. So this, the volume of this figure we have to figure out. And we know how we can do that by using integration. And the area of the curve, and this area of the square, we know what the formula is for that. Okay, so this was using squares. Similarly, we can do this with respect to triangles. Now let's see how we can do the same thing using triangles rather than squares. So again, we go to GeoGebra, go to 3D calculator, and let's start. We know A, we require a slider, B, slider. Let's say this is from -5 to 5. Okay, N we require slider from A to B in steps of 0.1. Our function is going to be x square by 9 minus 4. G of x is equal to -1. Okay. Now let's figure out the coordinates of the triangle. So coordinates would be n comma f of n would be 1. As you can see, this is the point. Okay, now let's look at the second coordinate that we require, that is this. So that would be n comma g of n. And now we want the third coordinate. So let us say n comma f of n comma 2, right? And let's connect these dots using polygon a comma b comma c. So we have got a triangle now. Now let's see what happens if I move n. If you position it properly, you will be able to see it much better, right? From different angles, you will have a different understanding. Ah, this is perfect, right? Okay. Now, what if I didn't want the triangle in this way? I wanted this uh, height coming at this point. Pretty straightforward. Instead of saying n f of n comma 2, we will change it to n g of n comma 2. Yes? And again, if I move this, triangle moves. Now here, if you notice, if I take it to the extreme, there still is some gap left. So that means my boundaries are not well defined. So what I have to figure out is what is this point where this green curve and the blue curve intersect each other. And those values I have to put it as our A and B. So intersect F and G from say -20 to 20. It doesn't matter. You just have to make sure that it falls between the intersections of these two curves. Okay. So now what else? We want the x values of these 2 points, right? So pretty straightforward, x of b and x of e. So you see point -5.2 and 5. Now what I'll do is I'll go here and change it to -5.2 to 5.2. And now if I play it, you will notice that actually goes to the intersections. Yes, it actually goes up to the intersection. Now let's again, as usual, let's make it retain the shadows, settings, show trace, and now let's actually visualize the solid that is being formed by this moving triangle. Okay. So now let's see what happens if I change it to -2. See, automatically everything changes. Shadows are still there, so you just zoom in or zoom out, and again you try that. But now, if you notice, here it is going beyond the intersection points, which we don't want, right? So again, look at the intersect points, x values, D and E, -4.24 and 4.24. So -4.24 and 4.24. And now let's remove that by zooming in, zooming out. And if you notice now, it won't go beyond the intersection point. It is going up to the point. Now let's see whether it goes up to this. Yes. So this is the solid that is formed, and the volume of this we have to figure out. Okay, I think you got the idea. Similarly, you can think of other figures for which you should know the formula for the um, area, because it is the area that you are going to integrate of these triangles to get the volume. So that's it. Bye.